Welcome back to the Weekly Tech Digest for week of July 13th, 2026. This week we cover 3 topics, including 202.60704 harness, structured prompt-driven development, SPDD, and the app read Redis_port. Kubernetes had already overwritten it. Let's get into it. Harness engineering is crucial for enabling recursive self-improvement in AI systems by optimizing the interaction between models and their deployment contexts. Harnesses structure AI model deployments. They orchestrate execution, manage context, and evaluate results, acting as a crucial bridge between raw models and real-world applications. Recursive self-improvement allows AI systems to use their intelligence to optimize their own performance through feedback loops involving model weights and deployment systems. Context engineering, which includes ACE and MCE, supports efficient memory management. ACE provides a structured context framework, while MCE evolves context management mechanisms through skill optimization. Auto-research accelerates AI model improvements. Successful coding agents demonstrate how harnesses can lead to self-improvement in models, allowing them to learn and adapt over time. Coding agent workflow consists of defining a loop of plan, execute, observe or test, and improve. This process iterates until the goal is achieved. Harness engineering optimizes the interaction between models and their deployment contexts. Feedback loops enhance AI capabilities, and context management supports efficient memory usage. How will advances in harness engineering shape the future of AI self-improvement? Structured prompt-driven development transforms how organizations manage AI-generated code by treating prompts as first-class artifacts. SPDD improves governance of AI-generated changes. By treating prompts as assets that are version-controlled and reusable, teams can ensure better alignment with business requirements. Reasons Canvas provides a structured approach to prompt creation. It helps clarify requirements and design intent, ensuring the large language model generates more predictable outputs. SPDD encourages iterative review and collaboration. By focusing reviews on prompt intent rather than just code quality, teams reduce variability and enhance shared understanding. The SPDD workflow creates a closed loop between prompts and code. Feedback from code changes updates prompts, ensuring both evolve together and stay aligned. The SPDD method enhances team efficiency and reduces misunderstandings. By capturing full specifications in structured prompts, teams avoid ambiguities that can lead to errors in generated code. In summary, SPDD transforms how organizations view prompts, improving governance, collaboration, and team efficiency. How could organizations improve AI governance with existing development frameworks? Kubernetes injects legacy environment variables that can conflict with application configurations, leading to runtime errors. Kubernetes injects service-related environment variables into each pod. This includes deprecated Docker link variables, as Kubernetes adopted the exact variable format in its first release. A naming collision can lead to application failures. If a service variable and an app variable share a name, the app will use the incorrect value that Kubernetes injected, which isn't even a number since Docker links formatted it as a protocol-qualified URL. There are specific solutions to avoid this issue. Developers can disable service links or explicitly set environment variables in the pod spec to fix collisions. These are 3 options, in the order I'd reach for them. To summarize, Kubernetes injects service variables, which can cause naming collisions that disrupt application performance. Developers have strategies to manage these issues effectively. How do you manage service variable collisions in your environment? That's everything for this week's digest. Links to every post are in the description below. Drop a comment. Which topic did you find most useful this week? I'll see you next Friday.